All right, so I said a little bit about what the meaning of vectors and matrices are. So a vector you can think of as a list of numbers that's considered as a single data item. Now, what do I mean by a single data item? For instance, you can have a vector of prices. If you have a supermarket and you have prices. Now, these are American prices, not Cameroon prices. So they may look strange, but so you have all the current prices, you put all of this information together, and this is considered as one data item. Okay? So the position in the vector matters. In this case, my first entry is the bread price, which I call B. Second entry is milk price, which I call M. Third entry is egg price, which I call E. Now you can arrange the vector as a row vector or a column vector. We talked about that before. Another common use of vectors is for locations in physics. I think, have you had a physics class here? Has everyone taken physics? Okay, some people yes, some people no. But if I want to specify the location of an object in space, you'll have three numbers: the x-coordinate, the y-coordinate, and the z-coordinate. So I can draw that. Where did my pen go? Oh, okay. I can draw that. Oops, disconnect. Typically, you make a coordinate system. You have the, if you have two dimensions, you would have the x-coordinate here and the y-coordinate here, right? And then my vector would be xy. So this is in 2 dimensions. In 3 dimensions, I would have a z direction, an x direction, and a y direction. And I'd have 3 numbers, x, y, z, which specify the position of this point. So still I'm considering this as a single data item. Okay? Another common use of vectors is as a vector of probabilities. Now, suppose you have someone who has a cancer, and you want to know what is the probability of this person recovering, which is a good outcome. The person will survive another 10 years, which is fair outcome, or the person will die in 1 year, that's poor outcome. So we have different possible outcomes for this cancer patient, good, fair, and poor. So we can assign probabilities to these different outcomes. Now, if you notice, 0.5 plus 0.2 plus 0.3, the sum of that is equal to 1. So when you have probabilities, the probability always has to add to 1. So all these probabilities together describe the condition of the patient. Okay? So in all these cases, a vector determines a single data item. Okay? So what about a matrix? A matrix is a table of numbers that expresses interrelationships between 2 vectors. Okay? So matrices are often used to describe systems that have a linear relation between inputs and outputs. Typically, inputs correspond to columns and outputs correspond to rows. All right, so that's a lot of words. Let me give an example. Okay. All right. So suppose you have 3 different people who are buying food: Mary, Joseph, and Dana. Okay, again, these are American names, but I'm American, so all right. Now, the Mary, Joseph, and Dana are all buying milk, eggs, and bread, but they buy different amounts. Okay? So the amount of money that Mary spends will depend on the price of milk, bread, and eggs. The amount of money that Joseph spends will also depend on milk, bread, and eggs. The amount of money that Dana spends similarly will depend on the prices. Okay. For instance, I have this picture down here. Here I have the, what I've done here is I've drawn the prices here. This is bread, milk, and eggs. Okay? This is Mary, Joseph, and Dana. And then I've drawn connection between each node here and each node here. All right? So, why have I drawn this connection? Well, Mary, let me make this bigger. Actually, let me make a copy of this because I'm marking on it, so let me make a copy. Copy. And then I'll paste. And that way I can make changes. So let me make this bigger so you can see. Zoom. All right. So these numbers are not quite so clear, but let's see. So, for instance, this 10 here. You see the 10 here. This 10 represents the fact that Mary buys 10 units of bread. Okay. So that's the connection between Mary and bread. Mary buys 10 units of bread. Okay. Similarly, this connection here, you see this 5. This 5 means that Joseph buys 5 units of bread. And then this connection here is labeled with a 25. This means that Dana buys 25 units of bread. Okay. So between each food item and each customer, there's a connection. And the connection has a number. And the number is the amount of that item that is bought by that customer. Okay. All right. Now, how much is Mary going to spend? Well, let's look at this. Mary is buying 10 units of bread. Now, if the price of bread is B, then Mary is going to spend 10B on bread. Okay. Mary is also buying milk. What's the amount of milk she's buying? She's buying 3 milks. Okay. So the amount of money she spends on milk is 3 times the price of milk. Then the amount of money she spends on eggs is 6 times the price of eggs. So this should look a little bit familiar. When we multiply matrices, we do something similar, right? You multiply 2 numbers together and then you sum together. So this is beginning to look like a matrix multiplication. So Mary has a price, Joseph has a cost, Dana has a cost. We have these 3. All right, so how do we represent this? Well, these numbers here that relate the items and the buyers, I can arrange in a table. So here I put what I call inputs, and inputs, these are the items. And then here I have outputs, these are the buyers. And then I take these numbers here and I arrange them in the table, right? Mary buying bread, that's the number on this here. Mary buying milk, that's the number on this line here that links milk to Mary, and so on. So I arrange in this table. Okay. Right. Now, on the other hand, I can also write down the prices. Let me write down the prices in a column vector. Okay. And I'll have to move over a little bit, which I write as BME. So here I have a matrix and I have a column. This matrix is 3 by 3. This column is 3 by 1. If I take the product of these two, that becomes a 3 by 1 product. Okay. And in fact, this 3 by 1 product is exactly this set of 3 numbers that I have here. The first entry is this, the second entry is this, the third entry is this. Okay. So we can see in this case, the matrix multiplication is expressing the relationship between the inputs and the outputs. So if I have this kind of diagram that has what you call a linear relationship between inputs and outputs, then you can use a matrix to find the result. Okay. Now in this case, I only have a vector of inputs. Okay. So, but I want to say, suppose I have two arrays. What does that mean? What does it mean if I have one array multiplied by another array, not just an array multiplied by a vector? So we now have matrix vector multiplication, and then let's see. All right, so I'll go to the next slide. That's this one. Copy and paste. Oh, sorry. Sorry, I don't want to do that. Let me just copy. Copy, and then I'll paste down here. Okay. All right, so this is just reviewing what I just said. It's a little bit neater. So we have our bipartite relationship, and we have a matrix here. So matrix vector multiplication. Now, we can classify this information in the matrix. The entry in row I and column J is the amount of material I. Let me see. Now I think I got this backwards because the row. Let me think about this. I think I actually have this. I think I actually have this backwards. I think this should be a J, and this should be I. Because the column is telling me my input, and the row is showing me my output. All right, so in this case, I had inputs and outputs. But suppose there's another stage in the middle. Suppose that you have raw materials, and you use the raw materials to make components, and then you use the components to make final products. All right. So, for instance, so if I do an example, I can have raw materials. Okay. Suppose I'm making chairs. Okay. So what are the raw materials? I need wood. I need nails. And I need labor. So that would be raw materials. Okay. Then I use these raw materials to make parts of the chair. I have the legs of the chair. Sorry. Oops. Okay. Then components. The components may be the legs of the chair, the seat, and then the back. Okay. And then you have final product. Well, perhaps I make different kinds of chairs that uses different combinations of these different things. So I'll say, so I have a fancy chair, a simple chair. Okay. So I have raw materials that I start with. I use these raw materials to make components, and then I use the components to make a final product. So there are two stages and not just one. Okay. So the first stage might be here, where I go from the raw materials to the components. And then the second stage, I go from the components to the output. Okay. And each one of these stages has a relationship. Now what I'm interested in is the relationship between the input and the output. How do I get the relationship between the input and the output? Well, I put these two individual relationships together. This input will influence these intermediate stages, and then each one of these intermediate stages is going to influence the output. Okay. So if I want the effect of the input on the output, I'm actually going to have to write two matrices. I have a matrix for this relationship and a matrix for this relationship. So if in this particular case, if I start with the original input, let me zoom out a little bit. All right, now the way I wrote this is here I have input 1. Input 1 is the input on the left here. So this input 1 relates to, let's see. This input 1 relates to the columns in this matrix here. Okay, please enter. Okay. And then these here, these are the intermediate inputs, outputs. So this part, can I change the color? Let's see. All right, I can change the color. All right, so these inputs, outputs here relate to these components here. So this matrix is giving me this relationship here. Okay. The second matrix is giving me the other relationship. So I can take this relationship here, these, and that's expressed in this matrix here. Now to get the final relationship between inputs and outputs, in fact, what I do is I multiply these two matrices together. One thing that you need to pay attention is that the relationship on the left corresponds to the matrix on the right. So the first set of, the first transition, the first relationship, you write on the right. Now, in fact, you've seen this before. If you take a function, if you take one function of another function, you write the first function on the left, on the right, and then you take the other function of that. Okay. So if I give an example, if I say, for instance, f of x equals x squared plus 2, and then g of x is equal to 9x plus 4, then if I take g of f of x, that means I'm taking the f of x first, and then I'm applying the g of x. So this means that f of x is first. Okay. The first function is on the right. The second function is on the left. Okay. So that's the same thing that's happening here. When I write these two matrices, the matrix of the first relationship is on the right, and the matrix of the second relationship is on the left. And you can see that these dimensions match. Let me erase this if I can. Let's see if I can erase this. Where is my eraser? Oh, it's here. Okay. You can see that the intermediate quantities here match the intermediate quantities here. So you have the same number of columns here that you have rows here. Everything is matching. Okay. So this is how matrices are giving me the relationship between my inputs and outputs. All right. So suppose in particular, I want the relationship between input A and output S2. How does input A affect output S2? Well, input A is going to affect each one of these intermediate states here. And then each one of these intermediate states is going to affect the final output. Okay? So I have these four numbers here for these four edges, W1, W2, W3, W4, U1, U2, U3, U4, and I'm going to multiply W1 times U1, W2 times U2, W3 times U3, W4 times U4, and add them together. All right, so you can see that this is the same thing as matrix multiplication. Let's see. All right. Well, let me stop here for a moment, and we'll take a break. Let's take a 10-minute break, and then we'll continue with the next part. But the idea I want to leave you with is the fact that matrix multiplication does express relationships between inputs and outputs. If you have a series of inputs and outputs, matrix multiplication gives you the final relationship. Okay, so let's take 10 minutes, and we'll come back at 9:35. Okay, so let me try to finish this discussion. I'm going to copy this picture because I'm going to use it again. So let me copy it down below. Okay, so let's think about these lines and how we're going to label these lines. Now, let me just label the inputs and outputs by numbers. So this is input 1, input 2, input 3. This would be intermediate 1, 2, 3, 4, and this would be output 1 and 2. Then I want to label these entries here. This goes from input 1 to output 1. So that means I'm actually going to I'm going to call this A11. Now this is from input 1 to output 2. And I'm actually going to call that A21. Then this will be A31. And then this will be A41. Sorry, it's not very clear here. But A21 goes from 1 to 2. A31 goes from 1 to 3. A41 goes from 1 to 4. Okay. And then I also have here, if I'm going from 1 to 1 here, this would be from B11. And then this from 1 to 2 is going to be B21. And let's just do, if this one from 2 to 1 would be B12. Wait a minute, I think I have this wrong. Sorry, I should not get confused like this, but I think I'm getting confused. No, this is right. Sorry, this is right. Okay, B21, B12. Then this would be B22, and then this would be B13, and then this is B23, and then this is B14, and this is B24. Okay. Now, the reason I label it this way is then I will want to arrange my numbers in a matrix using those indices. So let me push this down. And I think what I should do is make this smaller. So I can arrange the B matrix this way. You can see that the B matrix is going to have the number of rows is going to be equal to the number of outputs, and the number of columns is going to be the number of intermediate states. So I have 1, 2, 1, 2, 3, 4. I have B11, B21, B12, B22, B13, B23, and then B14, B24. Okay. Then for A, so this is the matrix B. And the matrix A is going to be similar. A has the number of intermediates is going to be the number of rows, and the number of inputs is going to be the number of columns. So I'm going to have this here. I'll have it like this. A11, A12, A13, A21, A22, A23, A31, A32, A33, A41, A42, A43. Okay. All right, now suppose I want to trace the influence of input 1 on output 2. Okay. So how is input 1 going to influence output 2? Well, input 1 influences, here, let me make this a little bit fatter so we can see it more clearly. Input 1 influences this, and then this influences this here. Right? So here I have, this one is A11 and B21. Right? So I'll mark that out, that's A11 and B21. Then the next one I have A12, and then this is B22, right? So A12, and then, all right, so did I do the, hang on, I'm doing something wrong here. Yeah, I did this wrong, sorry, it's not A12, it's A21. You see I wrote A21 here, so let me remove that. The next one is going to be A21, and then B22, right? This one is A21, this one is B22. This one here is A31, and then this is going to be B23. So A31 and B23. Let me erase this. Okay, sorry, it's not working. Okay. Let me just erase it. What happened? Go back. Sorry. Is it working? Okay. Sorry. Okay. So again, my first one was A11. My first one up here was A11 times B21. That was B21 and A11. Second one was A21, B2, and then B22. That was B22, A21. Third one was A31 and B23, so A31, B23. Last one is going to be A41 and B24. So that's this one here. Okay. So you see that what we're actually doing is we're taking this row times this column. This column was determined by input 1, and this row was determined by output 2. Okay, so the result is just going to be B21 A11 plus B22 A22 A21 plus B23 A31 plus B24 A41. Now this is called the inner product of these two vectors. So what I can say is that every entry of the product and every entry of the product matrix is an inner product of a row vector and a column vector. So let me just summarize that down below. Wait a minute, did I start recording again? Yes, I am. Okay. So every entry of a product matrix can be expressed as the inner product of a row, a vector, of the first matrix times a column of the second matrix. Let me get rid of this thing. Column of the second matrix. Okay. So that's the importance of inner product in matrix multiplication. And I could do that same thing for any relationship. If I wanted the relation of this one on this one, similarly, I would take all of these. I would take this one, and then I take this one, and then I take this one, and then I take this one. And you get an inner product together. So I hope you can see some relationship between this diagram and matrix multiplication. So I want to look at this relationship in a slightly different way. Let me move it down here. Now, instead of looking at one input and one output, I can look at the influence of each intermediate state. So I'm going to focus on one intermediate state. I'm just going to focus on one intermediate state. So let's look at this one here. Okay. Now, if you look at this one state has some arrows coming in from the different inputs. It has arrows coming in from this one, from this one, from this, and from this one. And then it also has arrows going out to this one and to this one. Okay. Now, what about these arrows coming in and these arrows going out? What does that correspond to in the matrix? Well, if you remember how I label this, when I label these entries, when I label these, let me put this 1, 2, 3, 1, 2, 3, 4, 1, 2. This arrow here, it goes from 1 to 2, so I call this A21. This arrow goes from 2 to 2, so I call this A22. This arrow goes from 2 to 2, goes A22. This goes from 3 to 2, so this is A32. Right? I'm sorry, A23. A23, thank you. Okay. Now this arrow here goes from 2 to 1, so this is B12. And this is going to be B22. All right. So here I have A21, A22, A23. These all have the same row, but different columns. So I have A21, A22, A23. Okay. Those are all of the entries that go into this intermediate stage. Now I also have B12 and B22. That's two different rows from the same column. So I have B12 and B22 like this. Now I can actually multiply this column vector times this row vector. But it doesn't give me a number, it gives me a matrix. This is 2 by 1, this is 1 by 3. So the result is 2 by 3. I get a 2 by 3 matrix. So if I do this multiplication, I'll get first row times first column, I'll get B12, A21, then I'll get B12, A22, and I'll get B12, A23, and then here I'll get B22, A21, B22, A22, and B22, A23. Okay. So that's my result. Okay. So what's the meaning of this matrix? How does this relate to the inputs and outputs? Okay. Now this is the matrix for intermediate step, stage, or stage or 2. I get this matrix considering the inputs and outputs from intermediate stage 2. But I have 3 other states that I can look at. Each one of these intermediate stages is going to have an input-output matrix. Okay? So similarly, I have input-output matrices for intermediate stages. One, 3, and 4. Now, if you think about how I would find those intermediate matrices, for instance, if I want the intermediate matrix for stage 4, what I would do is I would take all of the lines that go into 4 from here. So that would be, where are we? That would be 1. Okay, it's not really thick enough. Let me make it thicker. I can do that. So that would be this one. 1, 3. I would have those going in, and then out of 4, I'd have these 2 going out. So I would have a similar situation as this one, only instead of B12, B22, it would be B14, B24. And this would be A41, A42, A43. Okay. So the matrix would also be 2 by 3, but instead of 2's in here and the 2's here, I would have 4's here and 4's here. All right, so let me just do that particular example. So the matrix let me take this down again. So for example, for intermediate stage 2, for immediate stage 4, okay, then my matrix would look like this. Instead of the 2's, I would have 4's. This would be B14, A41, let's see, I think this is B14, A42, this would be B14, A43, and then this would be B24, A41, and then this would be B24, A42, and this would be B24, A43. Okay. So altogether I have 4 intermediate stages, and I have 4 of these matrices. And this is useful because each one of these matrices shows me the effect of the intermediate stage. Suppose there's some change to the intermediate stage. Well, it would change this matrix. Okay. So if I take the sum of all 4 matrices for the 4 intermediate stages, if I take the sum of all 4, what I get is the matrix product of A and B. Okay. Gives me the matrix product. And in this case, actually, it's B times A because my B is on the left and my A is on the right. Let me do a simple example to show you that that works. So, simple example would be something like this. Let's have my input and my intermediate and my output. And let's suppose I'll have 3 inputs and I'll have 2 intermediates, and then I'll have let's have 3 outputs. All right, so in this case, I'm going to have 2 matrices for the 2 intermediate stages. So if I label this one is A11, this one is A21, this one is going to be A12, and then this is going to be A22, and then this is going to be A13, and then this is going to be A23. And then similarly, this is going to be B11, then this is B21, and then this is B31, and then this is B12, and then B22, and then B32. Okay. All right, so let's first get the outer product for the first intermediate stage. So I will look at this one here. The outer product is going to be all the ones that go into here and go out of here. So in this case, what do I have? I have, this is, you can see it's A11, A21, A31. So that's A11, A21, A31. And then here I have B11, B21, B31. Did I do that right? No, I'm wrong, sorry. It's the other way. It's A1, this is A11, this is A12, and then this is A13. Okay. And then here I had my column, I have B, B11, B21, and then B31. Okay. So that's the matrix for this intermediate stage. Okay. Then if I take the matrix for the other intermediate stage, let me make that green. For the other intermediate stage, I'm going to have these other 3 here. Sorry, this diagram is becoming very messy. This one, and then this one, this one, this one. That's going to give me instead of A11, A12, A13, that's going to be A21, A22, A23, and then here I'm going to have instead of B11, B21, B31, this is going to be B12, B22, B32. So if I do the first matrix product, if I go back and do that, this is going to give me, it's going to give me B11A11, then B11A12, B11A13. Second one is going to be, this second one is going to be B21A11, B21 A12, and then B21, A13, and then finally I'm going to have B31, A11, B32, B31, A12, and B31, A13. Okay. So that's the red one. Now if I add the green one is going to give me what? This is going to be B12, A21, B12, A22, B12, A23. Next one, B22, A21, B22, A22, B22, A23. Last one is going to be B13, A31, let's see, did I do this right? B23, A32, and then B23, A33. No, I made some mistake, didn't I? Yes, sorry, this is not correct. This is not correct. I should be more careful. First one is B32, A21. I made a couple of mistakes here. This is going to be B22, not B12. That's B22, B22, B22. This is going to be B32, A21, B32, A22, and then B32, A23. I think that's right now. If you look at the patterns here, you have to look at the pattern. In here, the B is the same on each row. B12, B12, B12. B22, B22, B22. B32, B32, B32. And then the A's are the same in each column. A21, 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 A22, 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 etc. Okay. So now if I add these two matrices together, what do I get? I'll use a different color. So this is going to be B11A11 plus B12A21. Then I have B11A12 plus B12A22. And then I'm going to have B11A13 times plus B12A23. All right. Now, if you look at what this is, if you actually take this product here of, let's see, if I have B11, B12, and then and then it's going to be B21, B22, and then I have B31, B32. Okay, and then I multiply that by A11, A21, A12, A22, I guess it's this way. No, that's right. A13, A23. And I multiply these together. The first entry of this product is going to be B11A11 plus B12A21. And that's exactly the same as this entry. So the point I'm trying to make is that you can write a matrix product as a sum of outer products. And each outer product relates to each intermediate state. So let me just write that, and then we can look at some exercises. Right. Now, I believe that math is learned by doing, so I have created some exercises for you to do. So, so for the rest of the class, we'll work on exercises. and let's see how far we can get during the class. And the exercises are here. If you have the copy of the material, the exercises are under exercises, and it says matrix exercises. Now I can also show these on the screen. But before we start doing this, I want to make sure I have created a WhatsApp group, and I don't know how to invite. What's the best way to invite people? All right, now, if you have the material, the link is here in this links folder. Do you see where it says PK Focum WhatsApp group? Okay. So if you got the material from the USB and you look in the folder called links, you can join the WhatsApp group from there. Okay? Yeah, now I have internet again. Oh, but I forgot to bring my modem. Okay. I'll bring up my modem while you're working on this. Okay. So, all right. So we'll work on that as we do the exercise. So what I'd like to do now is work on these exercises. Okay. So I'll keep this on the screen so you can see it. And in some way, this is a repeat. All right, so I would like, as I said, I would like you to work on these exercises, and I would like to, well, I think what I'll do is I will collect them on Monday. So we'll see how far we get today, and you can have some chance to work on the weekend. I'll collect them on Monday. So I do want you to give me these exercises. So please start working on the exercises. See if you can read this. And this is very similar to what I've been talking about. So you start working on this. I'm going to get my modem, and I'll be back. Okay. So you can start working on 1, 2, 3, 4 exercises. Okay. So please go ahead and start. I'll be right back.
Est-ce que c'est clair? J'arrive tout seul déjà. Porque grava tomate, ele paga o meu carro para chocar no campo. Ele está me seguindo todo. Ele sai tarde e usa uma vez de volta. Ele mandou por dentro.
Yes, sure. Let me just get this up. Am I connected? Let me connect first. Sorry. All right, good. All right, good. So some people have been joining. Okay, very good. So it's working. All right, so let me put this up. Okay, did you have something? USB?
Fine. C'est maintenant que la même matière va dedans. Faut arrêter ça.
There are more exercises, not just this one. So there's several exercises here. So don't think that this is the only exercise. should stop the recording.